Welcome to Oxygen Frog. As always, I'm your host, Scott Fleischman, chemical engineer and the owner of Oxygen Frog. Oxygen frogs are self-sustaining oxygen systems for glass blowing. And today we're going to be covering the first piece of one of those systems, the oxygen concentrator, which actually pulls oxygen out of the ambient air around you and then concentrates it to send it to your torch. Now, air is about 21% oxygen, so there's a lot of it around that we can grab for free, but it's a little tricky. So let's jump right in. What we have here is a typical 5 liter per minute concentrator, and we've taken the shell off because today we're going to lay all its secrets bare. And what I'm going to do is I'm just going to go through each of these components and explain what they are and what it is that they do. First, we have the filter. What this does is keep dust and other particles from getting into the compressor and other parts of the machine. And please, you guys, change these every 6 months. Nothing will kill a concentrator faster than neglecting to change this filter. It'll save you a lot of money in the long run. After the filter comes the compressor, which is this device right here. And what this does is it compresses the air up to about 20 or 30 psi. When it exits the compressor, it's fairly warm, so it runs through this little heat exchanger here just to knock a little bit of the heat out. The compressed air then goes through the waste feed valve. And the waste feed valve directs that compressed air to one of the 2 sieve beds, while at the same time directing the waste nitrogen from one of the sieve beds to the muffler. And it switches these 2 back and forth about every 6 or 7 seconds. These here are the molecular sieve beds, and they're filled with zeolite molecular sieve adsorbent, which absorbs nitrogen, but it doesn't absorb oxygen very well. The reason why there's 2 is because these can only run for about 6 or 7 seconds before they're so full of nitrogen that it may start to come through the top with the oxygen. So while one is filling with nitrogen and producing oxygen, the other one is actually being cleaned and regenerated. Some concentrator models are equipped with a pressure equalization valve located at the top of the beds. This valve will open for just a fraction of a second to quickly raise the pressure of the regenerated bed right before the beds switch over. This ensures that the regenerated bed is ready to capture nitrogen right after the beds switch over. This step makes the system a little more energy efficient compared to machines that do not have this feature. Once the oxygen leaves the sieve beds, it will travel through some check valves and to the mixing tank. The mixing tank just stores a small amount of oxygen to ensure that the oxygen flow rate does not fluctuate when the beds are switching. Also, there is an oxygen delivery pressure regulator. And finally, the oxygen flow meter and the flow control valve. Never run your oxygen concentrator over its maximum flow rate for long periods of time. The immediate result will be low oxygen purity. The long-term result will be damage to the sieve beds. So imagine this is a sieve bed and that we have a piston up here. Now, real sieve beds don't have pistons, so we're just doing a thought experiment here, so just try to follow me on this. Now this just has air in it, and if we push this piston down, we would be compressing the air, and that would force all of the nitrogen down into the molecular sieve. We would be left then with a little layer of oxygen on top, and we could collect that oxygen and send it to the torch. That represents what happens in the production sieve bed. But now that we've grabbed the oxygen, we can lift the piston and let the pressure off, and then all this nitrogen trapped in the sieve would come back out, and then we can discard it. That's what happens in the bed that's being regenerated. So in a real machine, the 2 beds are continually switching back and forth between production and regeneration. And in this way, it can provide a continual steady stream of oxygen. Thanks for tuning in, guys. We hope you enjoyed this segment. And please like this video, subscribe, and also follow us on Instagram. And if you have any questions for us at Oxygen Frog, please check out our website and give us a call. So have a great day, everyone, and remember, ribbit, ribbit, rage it.